Introduction to Learning Outcome 2. So we're going to investigate the performance of two-port networks and design test attenuating filter circuits against a computer model simulation. So single assignment that I've already talked about, which is a lab report covering 2 practical labs, computer simulations. You're going to design an attenuator to specification, do a computer sim on preferred component values, and then do lab tests with real values that will have their plus minus 5% or 10% tolerance, whatever it is on them. So you would expect to move possibly a little bit further away from design then and evaluate that and whether you practically get within the tolerances generally of the components used. Okay, and then you're just going to do the same thing with a filter. The design for the attenuator, we're going to use an online calculator to get the values of the resistors required for that network. Okay, and then we'll probably use multi-sim to do a simulation, and then the filter, we actually use a little filter design software I found that's free, which is handy because you guys can get yourself a hold of that program called LC. We'll use that to come up with the component values for the filter and do the analysis of it. So we won't do the analysis of filters with multi-sim. We can do that directly in the LC program. Okay, so that's where we're going over the next 4 or 5 weeks. So two-port networks, basics. As the name sort of suggests, that's a network of components with 2 ports, an input port and an output port. Some networks require some kind of power supply for them to work, so that would be optional extra connections, but generally you've got 2 connection input, 2 connection output, and then any power, and those power connections or ideas on some schematics aren't shown. They just assumed that they might be shown on a separate diagram, the way the network needs to be powered. If all you're interested in is the signals through it, then you'll just leave them off for clarity. Okay, so the networks we're going to be looking at are non-powered. They don't have any external power. We're just talking about a network that's connected to a signal. Okay, with no external power. So the basics, a 2-port network in general, and we're going to look at 2 networks, an attenuator and a filter, takes an input, carries out some function on it to provide an output that is different, usually different in some way. There's a type of network that you'd call a buffer, which actually puts out exactly what goes in. But what you can think of it of is if you've got a long signal line, you'd start to lose signal over distance. So you'd put a buffer in that's effectively an amplifier to prop that signal up as you went over that several kilometers distance, for instance. So there are 2-port networks that put out exactly what you put in. They're called buffers. Okay. Examples: voltage reduction. That's one of the ones we're going to look at. An attenuator. We put 0 to 10 volts in, for instance. The action of that 2-port network is to reduce voltage by half. We get 0 to 5 volts out. Okay. Change of signal type. 0 to 5 volts DC input. Convert the voltage signal to a current signal. We might get a 4 or 20 milliamp signal out. And if you're in instrumentation, you'll understand about that. Various signal converters to go from one signal to another, and that might be a common one there. Okay, you could have one that goes the other way, 4 to 20 milliamps in, 0 to 10 volts out. Typically, that type of 2-port network would have some kind of power supply to it as well, because that'll have an electronic circuit in to do the signal conversion and amplification thereof. Okay, and then a third example, and that's the other one we're going to look at, an AC variable frequency in with the filter taking out all frequencies above 20 kilohertz, for example, so the output will only give you frequencies that are less than 20 kilohertz in frequency. Anything else will be effectively attenuated. What you can do, and I'll talk a bit more about this when we come to filters, but think of a filter as a variable attenuator. It's an attenuator that works. It's a circuit that attenuates at certain frequencies, but not at others. Okay? Yeah. You can think of a filter as being an attenuator that is variable in nature. That variable is around what the frequency is. So it will attenuate some frequencies and not attenuate others.
Is that what attenuate means?
Attenuate means reduce.
Oh, so
yeah. No, it could be anything, but in here it could be a current attenuator, but normally we talk about voltage attenuation. Yeah. Power attenuation. So you want to reduce power as well. All right, and more about that when we get to it. All right. Yeah. Sometimes there's other reasons to put attenuators in for purposes of impedance match, and we're going to touch on that a little bit, but not too much. So, one of those two types of those example networks that we are going to have a look at is the attenuator. Pause that there, I think.